Hello, my name is Mr. Fontenot. Welcome to my YouTube page, Mr. Fontenot 11. Please like, share, and subscribe. In this video, I will be calculating the values for a resistive, inductive, parallel complex circuit from the Chapter 16 Math Handout, problem number 25. Let's begin by taking a good look at how we're going to set our notebook up. So first here we see the circuit. It's a parallel circuit with a resistor and an inductor, AC voltage, and this is the way that you would set your notebook up for problems 25 through 32. All of the electrical quantities are the same except for theta. Now you're going to have theta 1 instead of theta z that you had before. Make sure you leave a little area to write down the steps that you took to solve the problem. Like I have here, I have all the steps written down, and that's really going to help you when you go back and rework the problem. If you get stuck, you can look over at the steps and see what your next step should be. So I want to remind you again that all of this information here has to be memorized so that you can write out your spreadsheet on your scratch paper to do your calculations. Sometimes you'll see VA and sometimes you'll see VT, but these are used interchangeably. There's no difference. VA is the same thing as VT. All right, so taking a look at problem number 25, I'll be getting my known values from the Chapter 16 Math handout shown here. And just taking a quick look over the math handout, you can see here that problems 25 through 32 are for parallel complex. If we zoom in here, we'll see that 25 through 28, you're given L. So you'll have to find XL using the correct formula, which I will show you in a minute. For 29 through 32, you're given XL. So you have to find what's missing that you need for the calculations based on what you're given. So we see here that we're given a total voltage of 15 volts, an inductance of 50 millihenries. L stands for inductance, and henries is the unit of measure of inductors. A coil being an inductor, so his symbol would be L, and the unit of measure for him is henries. So here we have millihenries using our metric prefix, times 10 to the negative 3 milli. The formulas we will be using are from the Chapter 16 formula handout. Here's a look at the entire handout. I will be putting a link in the video description below to print these if you need to. Otherwise, you could, if you don't have a printer, pause the video and write down the formulas. So right now we're going to be focusing on formulas 21 through 24. I do want to make it clear to you that whenever you're doing a resistive inductive parallel circuit, do not use any of the formulas for 17 through 20. Now we're going to be using formula 14. I'll show you that in detail here in a minute. But make sure you do not use formulas 17 through 20 when you are doing a parallel. Stay on this side of the line and do 21 through 24 for the parallel circuit. So let's get started here, and you'll see that I've already entered in my known values. My frequency here of 3.183 kilohertz. I also got from the math handout right here. You'll use that frequency for problems 25 through 32. All right, so I start with a total voltage of 15 volts, and I have a resistance of 1.5 k ohms. This being a parallel circuit, the first thing that I realize is that I have all of my V's. I was only given VT on the math handout, but understanding that this is a parallel circuit and voltage stays the same in parallel, I can go ahead and fill in all of my voltages. So that would be step number 1. Now that I have all of my voltages filled in, I can calculate the current through the resistor, IR. So I take my 15 volts over my 1.5 k ohms, and I get a current through the resistor of 10 milliamps. The next thing I'm going to calculate is my XL. And to do that, I'm going to use formula 14 from the formula sheet. You might want to circle that one on your formula sheet. So XL is equal to 2 pi FL. So I hit number 2. I hit shift engineering to get pi. 2 pi times, got to hit the multiplication sign, 3.183 kilohertz times 10 to the third. Make sure you do kilohertz or you will not get the right values. So 2 pi times F, I've got the F in there now for frequency, times L. So I'm going to say times, where is my L value? It's right here, 50 millihenries. That's what I was given from my chapter 16 math handout. So I'm going to take that value and punch it in, 50 times 10 to the negative 30 millihenries. And that's going to give me a value of, we're going to round that to 1K for XL. My next step, as you may have guessed, would be to find my IL, because now I have 2 out of 3 here. If I have 2 out of 3, I can use Ohm's law. So I'm looking for the IL. I take the 15 volts over my 1 times 10 to the third ohms equals, hit engineering, 15 milliamps. Again, I hope you realize how valuable writing these steps down is, because you're going to need to work these problems over and over. And if you get stuck, you can look at your steps. All right, so now my next step, step number 5, I'm going to find IT. And when I get ready to find IT, I have to use formula number 22. I want to make sure that you understand that you cannot simply add 15 milliamps to the 10 milliamps to get the correct value. So we're going to use formula number 22. The first thing I want to do is open the square root. Look at the calculator, you can see the button highlighted in blue. I'm going to open square root first. Then I'm going to put in my IR value of 10 milliamps. 10 times 10 to the negative 3, and make sure you put milliamps in there or you will not get the correct value. And I'm going to square that number. If I look at my formula right here, it tells me that it's IR squared. So right here is my squared button right next to the square root. So I'm going to square that number. Plus, I got the plus sign there, so plus IL squared. So that's 10, that is 15 IL is 15, 5 times 10 to the negative third. And I have to make sure I square it. It's easy to forget that. Squared. Way you don't forget it is you keep checking the formula to make sure you're doing it right. And I hit equals, I hit engineering, and my IT value should be 18.03 milliamps. Now, why can't you just add 15 and 10 milliamps together like we did when we were doing resistive circuits? Well, if you had two resistors here instead of an inductor and a resistor, you could just add them together. But in this situation with this complex circuit, having a resistor and an inductor, the voltage and the current is out of phase, meaning that it goes through the resistor and the inductor at a different point in time. So you actually cannot add them together because they are out of phase with each other. All right, so my next step is to find ZT, and I'm going to use formula number 23 to do that. I have my VT and I have my IT. So if I look at formula number 23, I can go ahead and find ZT. Z stands for impedance. Stands for impedance. Impedance is a certain type of opposition to current flow that we find when we have both inductive reactance and resistance. So just for a minute, I want you to understand there may be a test question about what does the Z stand for. So right here we have three different types of opposition to current flow. We have resistance measured in ohms. We have inductive reactance measured in ohms. And we're fixing to calculate impedance, which is also measured in ohms. So they're all oppositions to current flow. Therefore, they're all measured in ohms. But they are three different types of opposition to current flow. You have impedance, you have inductive reactance, and you have resistance. So, what is the value of ZT? I have a VA on the formula sheet. I have a VT here. Remember, they're used interchangeably. So I'm going to put in the 15 volts over 18.03 milliamps. And that's going to give me a value of 831.95, rounding the second number after the decimal place, ohms of impedance. And I mentioned the current being out of phase with one another, so let's see how much they're out of phase with one another by calculating theta 1. So we look at the formula sheet here. Theta 1 is equal to, we have to do inverse tangent. So our first step is to hit the shift button, then we hit tangent. Make sure you hit the shift button first before you hit tangent. And that goes for theta Z and theta 1. All right, formula says you got to put a negative symbol. It's right there. Look closely. Don't miss it. Put the negative sign, and then we're going to put in IL, which is 15 times 10 to the negative 3, over IR, which is 10 milliamps. 10 times 10 to the negative third. Scroll over first and then close the parentheses. It equals, and this tells us that it's negative 56.31 degrees out of phase. On the test, you will not have to put the degrees, you will have to put the negative sign, 56.31 degrees. All right, I hope this video helps you out. If it does, please subscribe to my YouTube channel. And if you've enjoyed this video and it's helped you, please leave a comment. I'd love for you to subscribe and leave a comment. And hey, you could share it on your Facebook page even. All right, thank you.